Hello, today we're going to start taking a look at compound probability, and in this video we're going to take a look at independent events. So first off, compound events are when more than one thing is happening. So there's two or more things happening either at the same time or right one after the other. And whenever we have independent events, spelled correctly now, the result of the first event does not affect the result of the second event. So what happens in the first event will not change anything about the second event at all. Some examples of this: flipping a coin. First off, if I flip a coin, whether it lands on heads or tails the first time will not change whether I get heads or tails the second time. Same thing with rolling dice. If I get a 6 on the dice once, that doesn't make it more likely to get a 1 or a 2 the second time around. Taking objects from a group, if they are replaced. So for instance, if I'm taking cards out of a deck, the second time I take a card out of the deck will not be affected as long as I put the first card back. So if I take a card out, draw 4, my chances of drawing a 4 are the same the second time, only if I put that first card back in the deck. A lot of times this will come up in problems. They'll talk about replacement, talking about putting things back. Whenever they talk about replacing objects, putting them back where they were, that's going to be an independent event. One of the things that we need to watch for is whenever we see the word "and" in a word problem, when we're talking about two events, that usually means we multiply. We're also going to see "or," but we'll talk about that in a later video. So remember, whenever you see the word "and," that's going to mean we're multiplying. So let's take a look at an example here. All right, here you are rolling 2 dice, should be dice. You're rolling 2 dice. What is the probability of rolling a 3 on the first one and a number bigger than 4 on the second one? So we've got two things happening. All right, hopefully that's a little bit easier to read. So we want to roll a 3 on the first die and a number bigger than 4 on the second die. Well, let's just look at these individually. How many number 3s are there on one die? Well, there's only one number 3, and there's 6 total sides, so that would be a probability of 1 out of 3. This is the first roll here, and let's write out our probability statement. So this is the probability of 3 and 4 or bigger. So probability of 3 and 4 or bigger. That's what the plus stands for here. We said that the probability of getting a 3 is 1 out of 6 because there's only one side on a die that has the number 3. And there are 6 sides total. Well, we also said that the word "and" means multiply. So I'm going to put a times right here. Our little dot there. And then a number that's bigger than 4. So bigger than 4, which numbers are bigger than 4? Well, that's 5 and 6. So we've got 2 numbers that are bigger than 4, so that's going to be 2 out of 6. Now we just multiply these two things together. So remember, when you're multiplying fractions, you just multiply all the way across. So you multiply your 2 numerators together, multiply your 2 denominators together. So 1 times 2 gives us 2. And 6 times 6 is 36. Now, we've got 2 out of 36, but what we want to do is we also still want to write this as a decimal. So take your calculator, divide 2 divided by 36, and you get 0.55555. Sorry, 0.055555. So 0.05 repeating. And that is the probability of when you roll 2 dice, rolling a 3 on the first one and a number bigger than 4 on the second one.